All right, this is the continuation of the heating and cooling curve notes. I'm not sure where the original video left off at, but pause this video so that you can draw the cooling curve. All right, so because we're cooling, kinetic energy is decreasing. Up top, it's increasing. So that's why next to all the sloped parts, I put kinetic energy is decreasing, potential energy is constant. I wrote that for all of these. When you go from a gas to a liquid, it's called condensation. When you go to a liquid to a solid, it's called freezing. At the flat parts, energy is spent changing its phase. So, from going to a gas to a liquid, the flat part, all the energy is spent changing all of those gas particles to a liquid. That's why there's no decrease in temperature, it just remains constant. And the same right here. I put here that the flat parts energy spent changing the phase. All right. And because it's cooling, we need to get rid of all of that high energy. So that's why as you go down, energy is being released. Up top, energy is being absorbed, the opposite. All right, so flip to the last part. We just got a few things. We're going to go over temperature, absolute zero, and heat. Okay. Temperature has to do with the average kinetic energy of the molecule. So it has to do with the kinetic energy. Average kinetic energy of molecules. So if the temperature goes up, will kinetic energy go up or down? Up. So that's what we call a direct relationship. So if temperature goes up, kinetic energy goes up. This is what we call a direct relationship. As one goes up, the other goes up. If one goes down, the other one goes down. Direct relationship. Heat is a form of energy. Okay, so put a form of energy. All right. The units for this are joules or kilojoules. This can be either kinetic or potential energy. Kinetic or potential energy. And absolute zero. So later on, so everyone has heard of Celsius, you've heard of Fahrenheit. In chemistry, there's another temperature unit called Kelvin. So we use the Kelvin scale a lot in any of our problems. So absolute zero is 0 Kelvin, which is a capital K, or negative 273 degrees Celsius. Yep, so Kelvin is the K right here. So the way that you can convert a Celsius temperature to Kelvin is just add 273 to it, and that makes it Kelvin. This is the temperature there where there's no movement, no particle movement. And that's it. No particle moving. So negative 273 is 0 Kelvin. So all you do for Celsius is add 273 to it and it'll change it to Kelvin. So when you add 273 to negative 273, that gives you 0. Yes.
What's the first word next to the right there?
Oh, form. Form of energy.
Oh.
For every 273 degrees Celsius there would be Kelvin.
Yep, so whatever Celsius you have, add 273 to it.
I know that Kelvin.
Yeah.
I'm gonna name my kid Kelvin.
Ooh, but you have to spell it like the science word, Kelvin.
Oh.
All right, so that's the end of the notes. What I want you to do is work on your heating curve practice problem. There are 7 questions. All right, so